The deeper we look into the universe, the more we realize how little we actually know. Each answer opens another doorway, and behind that doorway waits a paradox, something that refuses to fit neatly into what we believe is possible. These paradoxes don't just puzzle researchers, they haunt them. Some of the world's sharpest minds lose sleep wondering how a reality built on logic can behave so illogically. Imagine standing beneath a sky that stretches for billions of light years, filled with stars born long before Earth existed. You look up and think you understand what you're seeing: suns, planets, matter, energy. Yet almost everything that truly shapes the cosmos, gravity, time, quantum behavior, defies the very logic that allowed us to discover it. The more we measure, the stranger it becomes. Scientists once believed that if we observed precisely enough, every mystery could be solved. But the universe keeps secrets the way the ocean keeps its depths, revealing just enough to remind us how endless it is. Every paradox is a reminder that we are explorers inside something far greater than understanding itself. Take, for example, the simple question of time. We experience it as a straight line, a beginning, a middle, an end. But the equations that describe the universe refuse to choose a direction. On the cosmic scale, time can stretch, bend, or even stop. A clock on a spaceship moving near the speed of light ticks slower than one on Earth. A clock near a black hole slows even more. The universe doesn't treat time as a constant march forward. It treats it as a dimension that can twist. And yet, here we are, bound by its flow, aging, remembering, anticipating. How can the same reality feel both timeless and fleeting? Physicists wrestle with that question every day, because if time is flexible, then cause and effect, the foundation of science, also become uncertain. If that bends your mind, consider the next paradox, the double-slit experiment. When scientists fire single particles of light through two narrow openings, they expect to see two bright lines on a screen, one for each slit. Instead, the particles create a pattern of waves, as though each photon went through both slits at once and interfered with itself. Only when someone observes the experiment does the pattern collapse, behaving like particles again. What does that mean? It suggests that the act of observation, the simple awareness of measurement, changes physical reality. Reality itself may not decide what it is until it is seen. Think about that. The universe, 13.8 billion years old, may depend on observation to take form. If no one looks, does it still exist the same way? That question keeps scientists and philosophers equally restless. At first, these mysteries sound poetic, almost mystical, but they're written into the mathematics of quantum mechanics, the most accurate scientific theory ever created. Quantum equations can predict the behavior of particles to astonishing precision. Yet those same equations describe a world that seems impossible. It is as if nature allows both certainty and uncertainty to coexist, daring us to accept contradiction as truth. And that contradiction brings us to another cosmic puzzle, the paradox of Schrödinger's cat. In theory, a cat sealed inside a box with a quantum trigger could be both alive and dead until someone opens the box to check. It's a thought experiment, of course, but it highlights how quantum rules blur the line between possibility and reality. For something so small, the quantum world carries the weight of enormous mystery. Scientists try to reconcile this with the world we know, the tangible, predictable world of tables, trees, and galaxies. But the bridge between the quantum and the cosmic remains invisible. Somewhere there must be a rule that connects them, a single theory of everything. Yet every attempt so far collapses under its own contradictions. It's enough to make even the calmest physicist stare at the ceiling at 3 a.m., wondering whether the universe is playing by any rules at all. And that brings us to our first pause in this journey. If you're fascinated by these mysteries, if you've ever looked up at the night sky and felt both small and infinite, take a moment to subscribe to Know Your Sky. Each week, we explore the paradoxes that shape reality, the questions that science can't yet answer, and the wonder that keeps curiosity alive. Leave a comment with the paradox that intrigues you most. It helps us dive deeper together. Now, back to the sleepless questions of the cosmos. Among the strangest paradoxes is the one that hides in plain sight: gravity. We can measure it, predict it, and feel it every second of our lives. Yet no one truly understands what it is. General relativity describes it as the curvature of space and time, but quantum physics insists forces must come from particles, hypothetical ones called gravitons. The two explanations work perfectly in their own domains, but collapse when combined. Imagine a world where space curves so much it folds into itself. Black holes, for example. They swallow light, time, and even information. According to Einstein, nothing escapes. But quantum theory refuses to accept that information can vanish. It insists everything that exists must leave a trace somewhere. So which is it? Does a black hole erase reality, or does it store it in some unimaginable way? This information paradox sits at the heart of modern physics. If information can be destroyed, the universe loses its memory and every law of conservation falls apart. If it can't be destroyed, then something beyond our current understanding must preserve it, perhaps encoded on the event horizon of black holes themselves, like holograms on a cosmic screen. The more we search, the more reality looks like an intricate illusion, a projection of something deeper, unseen. Some scientists propose that our three-dimensional universe is a holographic representation of information existing on a two-dimensional surface. In that case, everything, galaxies, humans, dreams, could be the unfolding of data written in light. It sounds like science fiction, yet mathematics keeps pointing us back to that possibility. And that's what keeps physicists awake at night, the suspicion that reality may be both more real and less real than it appears. If these ideas feel impossible, that's because they are, and yet they work. Every time we test them, the results agree. The paradox is not in the math, it's in us. We keep expecting reality to behave like logic, but perhaps logic is only a small piece of reality's design. In this endless dialogue between curiosity and confusion, one truth remains constant. The universe doesn't owe us clarity. It gives us wonder instead. And maybe that's enough.
If the first paradox of the universe is that it exists at all, the second is that it exists in such balance, perfectly tuned, impossibly precise. For reasons that no one can fully explain, the laws of nature seem fine-tuned for life. Adjust the strength of gravity, the charge of the electron, or the rate of cosmic expansion by even a fraction, and the universe would collapse before it ever began, or drift into eternal emptiness. This improbable harmony is what scientists call the fine-tuning problem. It's the question of why the universe seems calibrated for complexity, for stars, for chemistry, for consciousness. The numbers that define reality look less like accidents and more like instructions. Some scientists argue that it's coincidence, born of chance, that with enough universes, one was bound to get it right. Others whisper that it feels like design, though they dare not name a designer. Imagine a symphony in which every instrument, every note, every vibration had to play in exact harmony for existence to occur. That's what the universe seems to be doing, performing with absolute precision without ever rehearsing. Even more puzzling is that this balance may not be stable. The universe appears to be expanding faster and faster, driven by something unseen, dark energy. It makes up nearly 70% of everything, yet we have no idea what it is. It's not matter, not light, not anything we can detect directly. It's simply there, pushing galaxies apart as though the cosmos itself were exhaling. Then there's dark matter, the invisible scaffolding of the universe. We can't see it, but its gravity shapes galaxies, bends light, and holds cosmic structures together. Without it, the universe would fall apart. Every atom, every star, every planet, including this one, is bound in place by something that cannot be seen. We are surrounded by invisible forces, living inside a mystery that outweighs the visible world by far. Scientists spend their lives trying to catch a glimpse of what dark matter truly is, building detectors buried deep underground, waiting for a signal that might never come. It's strange to think that all we've ever known, every human experience, every story ever told, comes from less than 5% of what actually exists. The rest is invisible, unknown, and silent. And yet, somehow, that silence holds everything together. If you're still watching this, you're one of the few who understand that these mysteries aren't discouraging, they're beautiful. They remind us that knowledge is not an ending, but a beginning. So, if you're enjoying this journey into the unknown, take a second to subscribe to Know Your Sky. Comment below what you think dark matter or dark energy might be. We read and respond to the most interesting theories. Together, we're building a community of cosmic thinkers who love asking impossible questions. Now, let's step even deeper into paradox. One of the greatest puzzles of the modern age began with something simple: the night sky itself. In ancient times, astronomers believed that the universe was eternal and unchanging. Yet, when telescopes became powerful enough, scientists noticed that galaxies were moving away from us, and the farther they were, the faster they receded. This observation gave birth to a shocking realization: the universe had a beginning. The Big Bang wasn't an explosion in space, it was the expansion of space itself. Everything, matter, energy, time, and even the laws of physics emerged from a single point smaller than an atom. And ever since that moment, the universe has been stretching, cooling, and evolving. But here's the paradox. If the universe began from nothing, where did that nothing come from? What triggered the spark of existence? Some physicists suggest that quantum fluctuations, tiny random events in a void, could have given rise to everything. Others argue that there was never truly nothing at all, because the laws of physics existed before the universe did. But that, of course, leads to another question: who or what created those laws? Each answer pushes the mystery further back. like an infinite chain of mirrors reflecting the same question: why is there something instead of nothing? And this, more than any other paradox, haunts cosmology. If the universe can emerge from nothing, then perhaps creation is not a singular event, but an ongoing process, an eternal blooming of existence across dimensions we cannot yet perceive. The more we learn, the more we realize that reality may not be one universe, but many, perhaps infinitely many. The multiverse theory suggests that our universe is just one bubble in an endless sea of universes, each with its own rules, constants, and outcomes. Somewhere out there could exist a version of you where the stars formed differently, where physics chose another path. To many, that idea feels extravagant, an escape from explanation. But for others, it might be the only way to solve the fine-tuning problem. If infinite universes exist, then ours simply happens to be one where life can emerge. The paradox, then, is not why it's possible, but why we are the ones observing it. It's an unsettling thought. The universe may be unimaginably vast, and yet consciousness, fragile, fleeting human awareness, has the power to look back at it and ask, why? Maybe that's the real mystery, not the cosmos itself, but the mind capable of wondering about it. In quantum physics, observation changes what is seen. In cosmology, observation defines what is known. The universe may have no meaning without a witness, and we, brief, conscious flashes of awareness, are the universe witnessing itself. This loop of perception, the cosmos observing its own creation through us, might be the greatest paradox of all. And that's what keeps scientists awake long after the data is collected, staring not at screens, but at ceilings, wondering whether the next discovery will answer anything, or simply open another door. The truth, perhaps, is that the universe was never meant to be understood completely. Its beauty lies in its refusal to end the conversation. And so we continue to listen, to the silence between stars, to the hum of galaxies expanding into infinity, to the paradoxes that make us human enough to keep asking. Time. It feels so constant, so familiar. Seconds pass, days end, and years fold into memory. Yet, for all our certainty, time may be the most deceptive illusion the universe ever created. In the equations that govern reality, time doesn't flow forward, it simply exists. The past and the future are equally real in the fabric of space-time. It's our minds that experience movement through it, like a flashlight scanning across a frozen landscape of moments. Einstein showed us that time is relative. It bends, stretches, and slows depending on speed and gravity. A second on Earth isn't the same as a second near a black hole. But what Einstein didn't explain is why time feels like it has direction. Why do we remember the past but not the future? Why do we grow older instead of younger? This question is known as the arrow of time, and it remains one of the most haunting paradoxes in all of physics. The arrow of time seems to point forward because of entropy, the universe's tendency to move from order to chaos. Ice melts, stars burn out, galaxies drift apart. Everything, from the smallest atom to the largest structure, follows this one-way descent into disorder. But if the fundamental laws of physics work the same forward and backward, why does time only move one way? It's as if the universe has a built-in memory, an irreversible unfolding that carries us ever forward, never back. Some scientists suggest that the Big Bang was the moment of lowest entropy, perfect order, and that everything since has been the slow unraveling of that perfection. But that explanation raises another paradox. Why did the universe start in such an ordered state at all? Why didn't it begin in chaos, the most natural condition? No one knows. Perhaps the arrow of time exists because consciousness demands it. A mind can only make sense of reality if events move in sequence, cause, effect, consequence. Without that rhythm, awareness itself might not exist. That possibility leads us to something even stranger, the relationship between time and observation. Quantum mechanics tells us that particles don't take on specific states until they're measured. Could the same be true for time? Could the act of remembering the past and expecting the future be what makes time real? If so, then reality might not flow at all. It might blink into existence moment by moment as consciousness observes it. That thought is enough to keep anyone awake at night. Scientists, philosophers, or anyone who's ever felt a strange déjà vu, as though the present were looping back on itself. In fact, physics doesn't rule out the possibility of time loops. General relativity allows for closed time-like curves, pathways through space-time that return to their starting point. In theory, if such a loop existed, you could travel into your own past. But here lies the paradox. If you can go back in time, could you change it? That's the grandfather paradox. The idea that if you went back and altered the past, you might erase your own existence. Logic collapses, cause becomes effect, and the timeline becomes a knot. To escape this paradox, some physicists suggest that the universe is self-consistent, that time travel might be possible, but you could never change anything that would create a contradiction. Every event, no matter how strange, must fit into one unbreakable narrative. Others argue that each change would split reality, creating alternate timelines, infinite versions of the universe, each holding a slightly different truth. If that's true, then perhaps somewhere, right now, another version of you made a different choice, and that version of you is watching a slightly different version of this same video. Time, then, isn't just a line. It might be a web, interconnected, infinite, and alive. And yet, even as we theorize about loops, wormholes, and multiverses, we're still trapped in one direction, forward. We feel time because we live it, one heartbeat at a time. Maybe that's what makes it sacred. If this kind of exploration fascinates you, the edges where science meets philosophy, then take a moment to subscribe to Know Your Sky. Leave a comment with your thoughts. Do you believe time is an illusion, or is it the most real thing we experience? Your ideas often inspire future videos, and together we're building one of the most curious communities on YouTube. Now let's venture into the paradox that connects physics to consciousness, the mystery of the observer itself. For centuries, science has worked to separate the observer from the observed. Objectivity was sacred. The experimenter was meant to stand apart from what they studied. But quantum mechanics shattered that illusion. When we observe a particle, its wave of possibilities collapses into one outcome. The universe seems to decide in response to our awareness. So what is consciousness? A byproduct of the brain, or something deeper, something woven into the universe itself? Neuroscience tells us that consciousness arises from neural activity, yet no one can explain how electrochemical signals become subjective experience. This is the hard problem of consciousness, how matter produces mind. Some physicists now propose the reverse, that consciousness doesn't emerge from matter, but that matter emerges from consciousness. Reality, they say, may be a mental construct, a projection of awareness itself. If true, then we are not observers of the universe, we are participants in its creation. Every act of perception adds a brushstroke to the cosmic painting. This idea, known as participatory realism, blurs the line between physics and philosophy. It suggests that reality is not fixed, but relational, a co-creation between consciousness and the cosmos. The more we study the brain, the more we find that it operates like a receiver, filtering infinite signals into the narrow band of experience we call the world. What if reality is broader than we can perceive? What if the universe is consciousness dreaming itself into form through us as us? This isn't mysticism. It's a question that scientists are beginning to take seriously. Quantum computers, neural simulations, and cosmological data are all converging on one uncomfortable truth. Information and awareness may be more fundamental than space or time. And if that's true, then the universe isn't made of matter at all. It's made of meaning. Somewhere between the equations and the questions, the universe looks back at us, not with eyes, but with understanding. It knows that we are trying to know it, and in doing so, it knows itself. Black holes. They are both the simplest and the strangest objects in the universe. Pure gravity, absolute darkness, and yet full of paradoxes that defy reason. When a massive star collapses under its own weight, it warps space-time so severely that not even light can escape. From the outside, a black hole looks like a void, but at its heart lies the most mysterious concept in all of physics: the singularity. It's a point where density becomes infinite, and the known laws of physics break down completely. Einstein's equations describe what happens around a black hole perfectly, but they fail at the center. Quantum mechanics, on the other hand, can't handle such extreme gravity. Somewhere between those two theories lies the truth, a grand unifying description of everything. Yet the universe keeps that secret sealed inside the darkness. But there's a deeper mystery. When something falls into a black hole, does it vanish forever? Einstein's theory says yes. Anything that crosses the event horizon, the invisible boundary around the black hole, is gone for good. But quantum mechanics says that can't be true. Information, the very blueprint of what something is, can never be destroyed. This conflict between relativity and quantum theory is known as the black hole information paradox. If information is lost, then one of the most fundamental laws of physics collapses. But if it isn't lost, then how can it escape something from which nothing can escape? For decades, this question has haunted scientists. Stephen Hawking famously argued that black holes slowly evaporate through radiation, but that radiation appears random, carrying no trace of the information within. Later in his life, Even Hawking began to doubt his own conclusion, suggesting instead that the information might be encoded at the event horizon, like data on the surface of a cosmic hard drive. This led to one of the most mind-bending ideas in all of science, the holographic principle. It proposes that everything we see in 3 dimensions, every galaxy, every atom, even your own body, might actually be a projection of information stored on a 2-dimensional boundary. In other words, the universe itself could be a hologram. Not an illusion, but a deeper kind of reality, one in which information is the most fundamental thing that exists. Space, time, matter, all of it may emerge from the way information interacts with itself. If that's true, then the black hole paradox doesn't destroy physics, it redefines it. What falls into a black hole doesn't vanish, it's transformed into information written on the fabric of space-time. Every star that dies, every planet that disappears, every human thought that ends, none of it is lost. It's absorbed into the universe's memory. That's a comforting thought, isn't it? The idea that nothing is ever truly gone, just rearranged, rewritten, remembered by the cosmos. But there's a darker side to this beauty. If the universe remembers everything, then perhaps it also replays it. Maybe what we call time is the cosmic memory in motion, a hologram unfolding itself frame by frame. Some physicists even suggest that consciousness might be part of this process, the universe experiencing its own stored information through awareness. In that sense, black holes aren't just destroyers, they're mirrors. They reflect the deepest paradox of all, creation and annihilation as 2 faces of the same process. It's moments like this that remind us why science isn't just about numbers, it's about wonder. If you've made it this far, you're clearly one of the few who still feel that sense of awe when staring into the unknown. So take a moment to subscribe to Know Your Sky, not just for more science, but for the journey itself. Leave a comment below. What do you think happens inside a black hole? We feature the most insightful thoughts in future videos. Now, let's travel deeper, beyond the event horizon, into the paradoxes that might reshape everything we think we know. Imagine you're falling into a black hole. To an outside observer, you'd appear to slow down, frozen just above the event horizon, fading away as light stretches into infinity. But from your perspective, you'd continue falling normally, passing through the horizon without noticing anything special, until space-time itself starts to crumble. 2 realities, both true, both contradictory. That's the strange duality of relativity and quantum mechanics. Each tells a valid story, but they refuse to agree on how the story ends. One says the universe is continuous and smooth, the other says it's granular, built from discrete quanta of energy. Somewhere between those 2 views lies the ultimate theory of everything, a single language capable of describing both the very large and the very small. Some physicists believe that string theory might be that language. It suggests that all particles are not points, but tiny vibrating strings, their frequencies defining everything from electrons to galaxies. Space and time, according to this view, are not static backdrops, but emergent patterns from those vibrations. Others lean toward loop quantum gravity, a competing theory that says space-time itself is made of tiny loops woven together like a cosmic fabric. Each loop carries a bit of information, and together they form the geometry of reality. Both theories aim for the same thing, to reconcile gravity and quantum physics. And yet, despite decades of effort, we still don't know which, if either, is right. The equations make sense, the universe doesn't. It's almost poetic that the closer we get to understanding reality, the more mysterious it becomes. The answers seem to retreat just beyond our grasp, like light vanishing at the edge of a black hole. But maybe that's the point. Maybe the universe wants to be pursued, not solved. For scientists, this pursuit is both torment and ecstasy. They chase the horizon, knowing they might never cross it. They fall into questions that pull them deeper the more they struggle. They stare into paradoxes not to escape them, but to learn how to live inside them. That's the essence of discovery, not to end the mystery, but to become part of it. So when we look up at the stars and see their light from billions of years ago, maybe we're not just seeing the past, maybe we're witnessing the universe remembering itself. Every photon that reaches us carries a story from the beginning of time, a whisper from the depths of creation. There's a question that sounds like science fiction, yet some of the most brilliant minds in physics and philosophy take it seriously. What if the universe is a simulation? It's a theory that makes even the most seasoned scientists uneasy, not because it lacks logic, but because it makes too much sense. We live in an age where virtual worlds are created by lines of code. Simulations can replicate weather, genetics, ecosystems, and soon, maybe even consciousness. So what if our reality operates on the same principle? This idea isn't new. Philosophers have long wondered if the world we see is just an illusion, from Plato's cave to Descartes' doubts about perception. But now, technology gives that question a new edge. If computers can simulate entire environments indistinguishable from reality, how can we be sure we're not already inside one? The simulation hypothesis suggests that advanced civilizations, possibly millions or billions of years ahead of us, could have developed the ability to create entire universes, complete with self-aware beings. And if that's possible, the math implies it's not only likely, but almost inevitable. Think about it. If even one civilization in all of existence develops the power to run simulations indistinguishable from reality, there could be countless simulated universes for every real one. The odds of this being the original universe, the one that started it all, are astronomically small. So if we are in a simulation, who or what is running it? Some envision hyper-advanced beings, digital gods existing outside our perception. Others think the simulators might not be beings at all, but self-evolving intelligences, cosmic AIs running endless models to understand themselves. Then comes the next paradox. If a simulation is perfect, can even its creators tell it apart from reality? Maybe the simulators themselves are also simulated, an infinite loop of realities within realities, each one believing it's the original. And maybe that's what the universe is, an eternal recursion, each layer trying to understand the one above it. Strangely, there's scientific evidence that flirts with this idea. The universe behaves like a massive information processor. Quantum states resemble bits, the smallest units of data. The laws of physics act like algorithms, executing with astonishing precision. Even the structure of space-time appears to have a digital texture, as if reality were pixelated at the smallest scale. The universe may not be running on a computer, it may be the computer. That leads us to another haunting thought. What if the simulation knows it's being observed? Quantum experiments reveal that observation changes outcomes. So if we're simulated beings capable of awareness, our very act of perception could alter the code itself. We might be the instruments through which the simulation observes its own operation, consciousness as both subject and program. If this sounds unsettling, that's because it forces us to rethink everything: choice, free will, morality, even death. If life is a simulation, does that make our experiences less real? Or does it mean that reality is far more complex than we ever imagined? After all, a dream feels real while we're inside it. Maybe reality is simply the universe's longest and most sophisticated dream. Before we go deeper, take a moment to breathe. And if you found yourself wondering what's real and what's illusion, you're in the right place. Subscribe to Know Your Sky and join a growing community that doesn't shy away from cosmic questions. Comment below what you think. Are we living in base reality, or is the universe a grand simulation of itself? The best responses often shape the topics we explore next. Now, let's continue this descent into the paradox of consciousness. Even if the universe is a simulation, there's one element that remains undeniably profound: awareness. Whatever the code, whatever the physics, something within us knows that we exist. And that knowing, that flicker of self-recognition, might be the most mysterious property in the cosmos. Where does consciousness come from? Most neuroscientists agree that it arises from the brain's immense complexity, but no one can explain how. Billions of neurons communicate through electrical impulses, but between those signals lies a gap, a bridge from the physical to the experiential that no theory can cross. Some call it the hard problem of consciousness, but maybe it's not a problem at all. Maybe it's a clue. Quantum physicists like Roger Penrose suggest that consciousness could arise from quantum processes inside brain microtubules, tiny structures capable of maintaining quantum coherence. If true, then consciousness itself could be a fundamental feature of the universe, not an accidental byproduct of matter. That would mean that consciousness existed before the brain, and that the brain is simply a receiver, tuning in to the universal field of awareness like an antenna catching a signal. It's a theory that transforms everything. Instead of the universe creating consciousness, consciousness may have created the universe. If awareness is fundamental, then matter, energy, and even space-time could be manifestations of it. The universe might not just contain consciousness, it is consciousness, exploring itself through form and experience. That idea echoes across cultures and philosophies, from ancient mysticism to modern physics, and it's starting to appear in scientific discourse more often than ever before. Some researchers now speculate that consciousness could be the missing link in understanding quantum measurement, the bridge between probabilities and outcomes. If consciousness shapes the quantum world, then reality is participatory, not observed from the outside, but co-created from within. It's an elegant idea. The universe, instead of being a cold machine, becomes a living field of intelligence, a network of awareness expressing itself in infinite ways. And perhaps that's why we ask questions in the first place. Maybe curiosity isn't just a human trait. Maybe it's how the universe learns. Each question we ask, each mystery we chase, is the cosmos wondering about itself through us. It's a humbling thought that behind every paradox lies not confusion, but consciousness looking in the mirror. So when scientists lose sleep over the mysteries of black holes, time, or quantum behavior, perhaps it's not just frustration, it's recognition. Somewhere deep inside, the universe knows it's being seen, and it wants to be understood.
What if the ultimate paradox is that there is no paradox at all? Only our limited understanding trying to make sense of infinity. Every mystery we've uncovered, from quantum uncertainty to black holes and time, seems to whisper the same truth. The universe is not bound by our logic. It plays by rules that transcend the human mind. Yet it allows us just enough comprehension to marvel at the design. Science often begins with certainty and ends in humility. The more we know, the more we realize how small our knowledge really is. Every equation that explains one corner of existence opens 1,000 more questions waiting in the dark. Perhaps that's not failure. Perhaps it's beauty. The universe was never meant to be solved like a puzzle. It was meant to be experienced, questioned, and lived through. When you gaze at the night sky, you're looking into a paradox that existed long before humans ever wondered. Some of the light reaching your eyes tonight left its stars before Earth even formed. You are, in this moment, seeing both the past and the present at once, a living contradiction made of light. The universe doesn't move linearly. It weaves itself into patterns that overlap and fold. Space bends, time stretches, particles dance between existence and potential. And somehow, amidst all this chaos, order emerges. Galaxies spiral, stars are born, life arises, and consciousness opens its eyes to the infinite. If there is any meaning to be found in this vast design, maybe it's this. Paradox isn't a flaw of reality. It's the signature of creation. Every contradiction is a bridge between what we know and what we don't. Every impossibility is an invitation to see differently. The double-slit experiment, the black hole information paradox, the arrow of time, they all point to the same direction, that reality is far more fluid than we believe, that perhaps matter, energy, and consciousness are not separate things, but expressions of one infinite field, shifting, dreaming, becoming. Some physicists believe this underlying field is quantum information, the fundamental fabric from which everything emerges. Others see it as a universal mind, a self-aware intelligence expanding through observation. Whatever name we give it, it's the same mystery looking back at us through 1,000 forms. In that sense, we are not separate from the universe trying to understand it. We are the means through which the universe understands itself. Every thought you've ever had, every feeling, every moment of wonder is part of that cosmic reflection. You are not looking at the stars, you are one of the ways the stars look at themselves.
When you think about it like that, even the smallest act of curiosity becomes sacred. Asking why is not just a question, it's an offering. It's how the universe keeps creating itself. But even within this beauty lies the one paradox that no scientist, philosopher, or thinker can ever escape: death. What happens when consciousness ends? Does awareness simply dissolve, or does it return to the infinite field from which it came? Physics can't answer that. Religion tries to, but even faith must live beside uncertainty. Maybe death isn't the opposite of life. Perhaps it's the continuation of it in a form the living cannot yet perceive. Maybe the energy that animates us doesn't disappear. It transforms, redistributes, and rejoins the whole. Every atom in your body was once part of a star. Every breath you take is made of particles billions of years old. You are literally built from the remnants of ancient light. And when your story ends, those atoms will scatter and begin again, carrying the memory of your existence into new shapes, new lives, new worlds. In that sense, nothing is ever lost, not in black holes, not in death, not in time. Everything changes form, but the music continues. If that thought gives you peace, hold on to it, because the universe may be vast and indifferent, but it's also profoundly connected. The same laws that shape galaxies guide the flow of your blood. The same forces that bend space-time curve the path of your thoughts. You are not small. You are the universe in motion, aware of itself for a fleeting moment. And that moment, right now, is everything. So, as we reach the end of this journey, through paradoxes, equations, and cosmic riddles, pause for a second. Feel the weight of existence pressing gently against your awareness. Listen to the silence between your thoughts. That silence is the same space that holds the galaxies. This is not just science. It's poetry written in gravity and light. If you've come this far, you're part of a rare group, seekers who don't fear the unknown, but embrace it. So if you haven't already, take a moment to subscribe to Know Your Sky. Leave a comment sharing which paradox struck you the most and why. We read every thought because your curiosity helps shape where this exploration goes next. Together, we're not just learning about the universe, we're remembering that we are it. The paradoxes will never end. There will always be new mysteries, new theories that shatter what we thought we knew, new discoveries that remind us how much more there is to understand. But that's the beauty of it. The sleepless nights, the unanswered questions, the equations that don't balance, all of it is part of the grand conversation between matter and meaning. So let the questions keep you awake. Let the wonder be your restlessness. Because the moment we stop asking is the moment the universe goes quiet. And as long as we keep asking, keep looking up, keep reaching for what can be known, the cosmos will keep whispering back. Maybe that's all it ever wanted, to be seen, to be felt, to be understood. And perhaps one day, when we finally connect every equation, when science and consciousness merge into one understanding, we'll realize that the answers were never hidden at all. They were inside us, written in stardust, reflected in awareness, waiting patiently to be remembered. Until then, keep wondering, keep watching, keep knowing your sky.